are moving along with rule number 4 of 5. It's going to be a bit of a negative class today because we're talking about negative powers, okay? And just like with the zero power property, we don't just make this up, okay? Like, what happens when we have a negative power? We have to actually sit down and mathematically figure out what's going on here, okay? And we do that by using patterns. I said earlier, algebra is all about patterns. Here's an excellent example of how. So we're going to fill up this entire space, so don't write super big. Try and kind of keep it proportional to the print size that I use here. But we're going to start with 2 cubed. Okay? Tell me what 2 cubed is. 2 cubed is not 4.
8.
2 cubed is 8.
I thought it was 2 times.
Okay? And why is it 8? What is 2 cubed in expanded form? 2 times 2 times 2, right? 2 times 2 times 2 is equal to 8. How about 2 squared? What's 2 squared equal to? 4. And of course, that in expanded form is 2 times 2. How about 2 to the first? That's equal to 2. Okay, because there's only one of them there, right? And at this point, I want you to look for a pattern. And then we're going to confirm that pattern in the next step. As we decrease our exponent by 1, from 3 to 2 to 1, what's happening to the value? Divide by 2, right? So if I now put in here 2 to the 0 power, this confirms the 0 power rule. What is 2 to the 0 power? 1, right? Any base to the 0 power is 1. And it still follows the pattern that we're seeing. As we're decreasing our exponent by 1, the value is being cut in half. So, mathematicians saw this, they looked at this, and they said, okay, so then what if we go negative? What if we have 2 to the negative first? What is that value going to be? 0.5, right? I heard some people maybe say negative something? No, right? If we follow this pattern down, our exponent's decreasing by 1, our value is getting cut in half. What's half of 1? 0.5, or we'll write it in fraction form, 1/2. Okay? If we decrease our exponent again, 2 to the negative second power, follow the pattern here. What's half of a half? 1/4. If we decrease our exponent again, now kind of coming full circle, we started with 2 cubed, we're ending with 2 to the negative third. What's half of a fourth? 1/8. Okay? And how this looks in expanded form, notice that for our values, for 2 cubed, we have an 8. 2 to the negative third, 1/8. 2 squared is 4. 2 to the negative second, 1/4. 2 to the first is 2. 2 to the negative first, 1/2. Basically what is happening here, if you wanted to write 2 to the negative third, well, we'll start here. 2 to the negative first in expanded form, there's only 1 2 and 2 to the positive first. 2 to the negative first, there's still only 1 2, but where is it? In the denominator. Okay? 2 squared was 2 times 2. 2 to the negative second is still a 2 times 2, but where are they? In the denominator. That's how you get 1/4. 2 cubed, 2 times 2 times 2. Where do you think the 2 times 2 times 2 is in 2 to the negative third? In the denominator. That's how we get 1/8. Okay? So a negative exponent, the reason why it's negative is because it's in the wrong spot. Right? If you have 2 to the negative first, it's actually equivalent to 1/2 to the positive first. 2 to the negative second, right now it's in the numerator. It's actually equivalent to 1/2 squared, that 2 squared being in the denominator. 2 to the negative third, right now as it's written, numerator, that's equivalent to 1/2 to the positive third, or 1/8. So a negative power does not make the base negative, right? There's no negativity over in our value side here. All that's telling you is that it's in the wrong part of the fraction. Let me prove it to you or show you in a different way, something you're familiar with. When we had in CO11 something like n cubed over n to the 7th, and we simplified this, and I said, where do you have more n's and where will they be? What is the answer to this one? And n to the 4th, and where are those n's? On the bottom, because that's where we have more to start with, right? This is equal to, these three n's cancel out, 1 over n to the 4th. If you use the rule for CO11, where the powers are subtracted, and you subtract 3 minus 7, what do you get? -4. As it turns out, these two things are the same. Right? I didn't tell you to take 3 minus 7 to get -4 because we haven't talked about negative powers yet. The way I phrased it was, where are there more n's and how many more are there, right? But if you, I told you start with the larger power, but you could do it the other way too. 3 minus 7, using that CO11 rule, 3 minus 7 is -4. But if you start with the 3, it means that -4 is in the numerator. You switch it, it's in the wrong part of the fraction. It's actually in the denominator. Who have I 100% confused right now? Only a couple. That's not too bad. Whose minds are just blown? Oh, okay. More. That's good. Okay, fantastic. Right? So negative powers do exist. They actually don't let them be more complicated than they are. All they mean is that whatever the base is, it's in the wrong part of the fraction. Okay? Can I erase this to go down to the rule, or are we still kind of jotting stuff down? Good? Okay. So the rule for a negative exponent, or coefficient, or base here. Okay? Are coefficients affected by the powers? Have they ever been? No. So are they in the wrong part of the fraction? They are not. The coefficients are unaffected, and they stay put. If they're in the numerator, they stay there. If they're in the denominator, they stay there. They don't move. And the reason being, coefficients are not affected by the power. The exponent, okay, I should say, the exponent moves with the base to the other part of the fraction. What? Moves with the base to the other part of the fraction. And now that you've moved it, you've put it in the correct spot, that exponent becomes positive. It's no longer unhappy being where it's at. Once it's moved, it becomes positive. As we saw in the example where we had n to the -4th, we moved it to the denominator where it should be, and now that exponent's positive. Okay? Moves with the base to the other part of the fraction, becomes positive. And the base, we're kind of back to normalcy here. In every other rule except for CO12, what happens to the base? Stays the same. It moves with the power, but it stays the same. Okay, it moves with the power, but it stays the same. Let's look at the first row of examples here. 7n to the -3rd. We see that -3 as a power, which means the n is in the wrong part of the fraction. That's all the negative power means. It just means that we need to move it. And right now, what part of the fraction is it in? In the numerator. So we're going to move it to denominator. Does the 7 go with it? No, it's a coefficient. Right? So this is what's getting moved, the n to the -3rd. The 7 stays put. That's still going to be in the numerator of the fraction. And now in our denominator, the base doesn't change, and the exponent becomes positive. So 7n to the negative third is equivalent to 7 over n to the positive third. All the negative power means is that it's in the wrong part of the fraction. So we put it in the correct part of the fraction, and we're done. That's it. Okay? Don't make this harder than it needs to be here. The next one, 12x to the negative ninth y. What gets moved here? What base gets moved, Aiden?
The x with the exponent.
Right. Nothing else. The 12 is a coefficient. That's all good. The y, what's the exponent on the y? Positive 1. So it's in the right part of the fraction. The only thing that we need to move is the x to the negative ninth. And since it's starting in the numerator, we're going to move it down to the denominator. The 12 and the y don't get touched, right? And it's over x to the positive ninth. Okay. The next one. What's getting moved? Evan. N to the negative fifth. Where's it moving to? The numerator. Okay? If it starts out in the denominator, well, that just means it gets moved up then. Right? It's just in the wrong part. So the 2 stays where it's at. It's a coefficient. It's a number, positive power. No reason to move that at all. The n to the negative fifth goes up top, becomes n to the positive fifth, and that coefficient of 3, again, just stays where it's at. All right? Last one. Everything's wrong. Okay? The t to the negative third, wrong spot. The c to the negative 10th, wrong spot. We're moving both of them. The t to the negative third goes down. The c to the negative 10th goes up. Becomes c to the positive 10th over t to the positive third. Okay? Those who I had 100% confused earlier, are we better now? Okay? Just think about the negative sign. It means it's not happy where it's at. Right? Got some negative vibes going on there. So we move it, and then positivity. Okay? Sure. Right? Okay, move on. Are we all good? Okay. Down a row, next one here. You talk about the 18a to the negative fifth. Yeah. So 18a to the negative fifth, b, c to the negative first. What's getting moved? A to the negative fifth, right? Got a negative power there. Anything else? C to the negative first. Okay. The 18, what is that? Why is that not getting moved? It's a coefficient. It stays where it's at. Why don't we move the b there? It's happy, right? What's the power on that b? Positive 1. It's not written because if it's positive 1, we don't have to write it. If it's a negative 1, you do to show that it needs to be moved, right? But we're only moving those bases with the negative power. So in our numerator, we keep the 18, we keep the b. In our denominator, a to the positive fifth, c to the positive first. If you want to write the positive 1, you can. Now you don't have to, because it's positive 1, right? But no harm, no foul if you do. Okay. Take the next 2 minutes or so and do these other 3. Check your answer with the partner. And then I will assign you your Wednesday night homework. Yay! Focus on what's being moved. What's in the wrong part of the fraction? Okay. What'd you get for the first one? 1 over h to the negative first. This gets moved. Aiden?
H to the 1 power over 1.
Yeah. You could have h to the first over 1, or just simplify it to be h, right? Essentially, this moves up top, so it becomes the numerator of the fraction. And since it's h to the positive first in the numerator, we don't have to write any of these other ones there. Okay. The third one, b to the negative 9th, that needs to be moved. N to the negative 7th, that needs to be moved. The b to the negative 9th goes down. The n to the negative 7th goes up. We're going to put them in the correct spot in the fraction. So a squared stays where it's at. The n now to the positive 7th joins it. Now it's in the correct place. B to the 9th in the denominator along with the y to the 11th. And that is your simplified answer. And then lastly, 4y squared n to the negative 2nd, only one base to move here. This n to the negative 2nd, 4y squared still in the numerator, and now in the denominator n to the positive 2nd. Okay?
How was our homework?
Your homework for tomorrow is going to be a grand review of the 4 rules we've covered thus far. If you look at the next page,
Are you recording?
I am. I think so. I should be. If you look at the next page, I've got 1, 2, 3, 4 rows of questions here. The first row is CO10, multiplying by the same base. It's a review. Okay. Second row, CO11. You see those fractions? Dividing by the same base there. Third row, I see a bunch of 0 powers. Must be talking about CO12 here. And then last one, CO13, a review of negative powers. Kind of a grand review of everything. Okay? So, what was that, 12 questions? 16? 16 questions due for tomorrow. The goal is for you to use the rule, so only use expanded form if you must. If you forget the rule, you need to write it out. You got to just verify that you're doing it correctly. Expanded form can be a tool, but it's much more efficient to use the rule, and that's why I want you to be using. Okay? Questions, comments, concerns, complaints, compliments, congratulations, criticisms on CO13. 13 is prime. Yes, it is. 13 is prime. All right, folks, that's how math.